Okay, so today we're going to estimate products and fractions. Boom. So what does that mean? That means we're going to demonstrate. First thing we're going to do is we're going to demonstrate how we can use a bar diagram, which is what we did yesterday. You guys all remember our bar diagram, right? So yesterday we did these things, and we used them to solve multiplication problems with fractions. So today what we're going to do is we're going to use them to estimate products. Now, somebody remind me, what does estimate mean? Big red. Halfway there. Estimate. What does estimate mean?
Round and solve.
Round and solve. Okay? The solving part's important. If you don't solve it, you're not estimating, you're rounding. Okay? So when we say let's estimate the product, you need to make sure that we're solving it as well. Okay? Now, we're going to use compatible numbers. What does that mean? Yes?
Numbers that fit the problem best.
Numbers that fit the problem best. In other words, numbers that are easy to work with. Okay? When we're looking at 3/5 times 19, we have a fraction and we have a whole number. So what we're going to do is we're going to take and we're going to round our whole number to the nearest number that is easy to work with, our denominator. So our denominator is 5 in this case, right?
Yep.
So we're going to count by 5s until we find the closest number to, in this case, it's 19. So we're going to count 5, 10, 15, 20, 25. So I just went over 19, right?
Yeah.
Okay, so what was my first number over 19? 20. What was my first number below 19?
15.
So what I want to know is, by counting by 5s, I have the first number below and first number over. Which one of them is closest to 19? 20 is closest. Okay? So that means we're going to take 19 and we're going to make it 20. Okay? That's all we're doing. Now, we'll talk some more about it in a little bit. Once we're here, it's yesterday.
Yeah.
We're going to come down here. We're going to go to our bar diagram. We're going to say it's 20. I have 1, 2, 3, 4, 5 spots. What number needs to go in each of those spots to make 20?
5, 10, 15, 4.
4. Because since there are 5 spots, since there's a 5 here, this is 20 divided by 5, which is 4. Okay? So the 4 goes in each of these boxes. 4, 4, 4, 4, 4. Now, how many of those boxes am I going to use for my answer?
3.
3. My numerator is 3. So right here, the numerator is 3. So 3 of these boxes make up my answer. So 3 4s is 12. Okay? This is last night's homework, but with estimate, with rounding. Okay?
Are we going to do it on our board?
Now, this is where it's going to get, I wouldn't say tricky, but trickier. They want you to round fractions to the nearest half or 1 because they're easy to work with. So when you're multiplying 2 fractions, they're going to say round to the nearest half, round to the nearest 1. And then they give you a number line that's got 0, 1 half, and 1 on it. I don't like it. I think that this is difficult. The reason why I think this is difficult none of those are the same. Well, how can you compare fractions without like denominators? Can you compare fractions without like denominators?
No.
I don't think so. Denise, you need to move Devin to you. Devin, move the white seat. Ella, will you please switch spots with Denise? Thank you. I'm sorry, I'll look. I appreciate it though. You two need to make sure that you sit apart from each other for now. Haven't I said that before?
Yes.
Many times.
Many times. Like a spot right there.
So this is something that I already told you guys previously.
I 5 times, yeah. She just sat down.
Okay, because you've been told not to sit next to each other, right? Am I right? And you did it anyways? So get your thing. Both of you, get your thing. Because you were sitting next to each other yesterday too, and I didn't take it. Okay. So what I'm going to suggest is a much easier way of figuring out whether this is 1/2, 1, or 0. So we're going to start with 11. Okay? We're going to get rid of their stake. And we're going to do this. We're going to draw a line. That number line is going to go from 0 to 11. What's half of 11? I'll be right there. What's half of 11? Yes? 5.5. And then we're going to put our 5 on that number line. What number on that number line, 5.5, 11, or 0, is 5 closest to?
5.5.
5.5, which is what? 5.5, which is half of 11. So we're going to round 5/11 to what? 1/2. Hello? Hey.
Oh.
Okay.
Okay. I don't.
All right.
Wait, how do you not get it?
Well, I already gave it to her yesterday. She just hasn't finished it, so I was going to finish it anyway. Okay. Okay. So if it's closer to 5.5, which is half of 11, we're going to round it to 1/2. Right? So the middle number is going to be 1/2. This is going to be 1, and this is going to be 0. So we're going to round this to 1/2. Now the same thing goes. Our next number, we have a what on the bottom?
8.
An 8. So we're going to make another number line with 0 and 8. What's half of 8?
4.
So 0, 1/2, 1. Then I'm going to put a number on the number line. I'm going to put 7 on the number line. Well, 7 is all the way over here. So what's 7 closest to? 0, 4, or 8?
8.
Because it's closest to 8, it's going to be
8. 1.
1. Okay. Now anything times 1 is what?
1. Itself.
Itself. So 1/2 times 1 is 1/2. Okay. So I think that this is easier because I know that if it's in the middle of my number line, it's half. If it's to the right of my number line, it's 1. And if it's over here, it's 0. Now I don't have different denominators on all the numbers. Okay? You guys see what I'm saying?
Yeah.
So, we'll do a couple more. Okay? So, here we go. So we have 2 5/7 pounds, and about how many pounds do 6 train? A model train car weighs 2 5/7 pounds. About how many pounds do 6 train cars weigh? So we're going to have 6 times 2 5/7. Okay. They want you to estimate. Well, the easiest way to estimate here is to go to the nearest whole number. Now, estimating is weird. If you can support how you rounded, as far as I'm concerned, you can be right. So in this case, 5/7. Half of 7 is what?
3.5.
Is 5 closer to 3.5 or 7?
3.5. 3.
Okay.
3.
So 5 is closer to 3.5 than 7. Okay. 5 is 1.5 spaces away from 3.5. It's 2 spaces away from 7. So you can make an argument that you should round this to. And you can tell me, Mr. Bedwell, this is an easy problem, because 6 times 2 is what?
12.
What's half of 6?
6.
Half of 6 is 3. What's 12 and 3?
4. 15.
12 plus 3 is
15.
15. So this is 15. So you can say, Mr. Bedwell, those numbers are easy to work with. However, you can also say, Mr. Bedwell, I rounded to the nearest whole number. If I wanted to round this to the nearest whole number, it's an addition problem. 2 plus 5/7 equals 5/7. We're going to round it to 0 or 1? 1. So you can go 2 plus 1 equals 3. And you could say that 3 times 6 equals 18. Can I support this? Can I support the way that I did this? Can I support the way that I did this? So if you pick a way, just go with it. If you rounded it to the nearest half, you said it's easy to work with for me. I know half of this number is 3. I know that when I multiply it, it comes out to 15. Or you can go whole numbers and say that it's 18. So either one of these answers, I would take from you. It's an estimation. It is not exact. That means that as long as you can support the way that you were rounding, you can say, Mr. Bell, I rounded to the nearest half, and this is what I got. Okay? So when you're looking at the answers tonight, and some of the answers, maybe one of them doesn't match what you got, and you say, well, they rounded to the nearest whole number, and I rounded to the nearest half. Okay? It's still an estimation, isn't it? Okay. Now, about 1/3 of the containers of the yogurt box are strawberry. This is in your book. You might want to make sure that we do this. If the box contains 17 containers, about how many containers are strawberry? So, when we are estimating, we always look at the denominator when we are doing, this is 1/3 of 17, or 1/3 times 17, because of and multiplication, we can swap them, correct? Okay. So, in this case, our denominator is what number? What? 3. So we are going to count by 3s until we get a number that is close to 17. The closest. So we're going to look at the number below 17 and the number above 17. And we're going to decide, okay, which one is it? Okay? So I'm going to count by 3. 3, 6, 9, 12, 15, 18. I just went over 17, right?
Yeah.
So what were the two numbers that I can look at?
15. 18.
15 is below it. 18 is above it. Which one is closer?
18.
So we're going to go with 18. Okay? 18 is 1 away from 7. 15 is 2 away from 7. Yes?
What happens if,
Okay? So, now we can solve it. We change this to 18, which means we can use our bar diagrams just like last night. Everybody like last night's homework?
Yeah.
All got it done?
That was easy.
Fantastic. Today's the same thing, except you have to make a number that is easy for you to use. So now I have 18 up here, right? So I have 3 boxes. Those 3 boxes have to add together to equal 18. What do I need to put in those boxes?
6.
6. Now our numerator, the number on the top of our fraction, tells us how many boxes we need. How many boxes do we need for our answer? 1. What number is in that one box?
6.
Okay, so we have 6 in each of the boxes, and our answer is 6. So about 6 yogurt containers are strawberry. Okay? Yes, sir.
So when you round, it's the number closest to the number you already have.
So in our case, we had 17 to begin with. We could go to 15, or we could go to 18. And if you had your number line, We'd have 15, 16, 17, 18. Well, that's just 1 away from here, 2 away from here. So we go to the closest number.
Why didn't you use 16 instead of 15?
You couldn't use 16 because 16 is not a compatible number with 3. Remember we counted by 3s because that was our numerator? Okay. So see, right here, the 3. So I count by 3s. 3, 6, 9, 12, 15, 18. Because it has to be something that I know that can be divided by 3
Oh,
easily.
okay.
How do you get 6 and it's multiplying 1 3 and 18?
So 6 times 3.
6 times 3 is 18. So you got 18. You take 18 and you divide it by the numerator, which is 6.
I forgot about that.
So 6, 12, 18 when you're counting. All right, any other questions about this one? No? Fantastic. Okay. They tell you whole number. If they don't tell you whole number in here, you could get a couple different answers because you can round to the nearest half or you can round to the nearest whole number. They tell you to round to the nearest whole number, so you need to make sure you read directions so you know. If it says nearest whole number, round to the nearest whole numbers. Okay? Now, when you're rounding mixed numbers, I know we've done this, but you need to just act like you're rounding an addition problem. Estimating an addition problem. 7 plus 2 sevenths equals. You're going to take your fraction from your mixed number and you're going to round it to the nearest whole number. In this case, our 2 sevenths. Is it closer to 0 or 1? What? Well, let's see. Here's my number line, right? 7's over here, which is equal to 1. 0 is here. 1, 2, 3, 4, 5, 6, 7. Here's 2. Is 2 closer to 0?
Yes.
Or is it closer to 7?
0.
So 2 sevenths is going to round to 0. So we're going to have 7 plus 0, which is 7. So this rounds to 7. Now we have 3 and 7/8, right? I'm going to take my number line. I'm going to add a line. That's 8. Here's 7. So now I have 3 plus 7/8. Or 3 plus 7/8 is going to round to what number? 1. So I'm going to round this and we're going to get 7 times 4, which is about 28. So far, so good.
You skipped example 2.
Huh?
You skipped example 2.
Did I?
Yeah. That's what I was trying to tell you about.
Alright, let's go over. You didn't have it.
You don't have it.
Wow. I'm sorry. Let's see. Okay, example number 2 that was in your book.
2.
Alright, so example 2. We have 2/5 plus 6/7. We're going to use number lines around the fractions. They do the same thing here. Look, in order to round these fractions, they have, how many different denominators are here?
3.
3. So I don't like that. I don't like that at all. So I would not do it this way. If you decide to do it that way because you think it's easier, that's fine. But in my opinion, I think if we make a number line and we use 0 and we say, okay, the first one, 5. Half of 5 is what?
4.
What's half of
1.
5?
2.
2,
1/2.
2.5. There's my number 2. What's it closest to?
0.
What's it closest to?
2.5.
It's close to 2.5, which is going to make it what?
1/2.
1/2.
1/2. Then we take our other number line. I'm sorry, not 6, it's 7, right? So 7 is our other denominator. If we have 0 and 7, what's half of 7?
6.
What's half of 7?
Oh.
7.3.
6.5.
Kirby?
3.5.
3.5.
Oh.
So there's our 6. What's 6 closest to?
7.
Which is going to round to 1. So we have 1/2 times 1. Anything times 1 is
12.
itself. Anything times 1 is itself. Not
I
1.
thought you said 1 times 2. But now I know that you did.
Okay. So that's your other example. Okay. I like these number lines better. I don't have 3 different numerators that I'm trying to figure out. Okay. Hopefully you guys think they're easier too that way. Because when you're looking at 3 different numerators trying to figure out where they fit on the number line, it doesn't, I don't like it. So, there's a reason why we tell you to find a common denominator. I mean, 3 different denominators when you're looking at. We tell you to find a common denominator when you compare fractions, right? But yet when you're rounding, they're showing you to round it with 3 different denominators. Doesn't make sense. Yes?
We're going to have a test tomorrow.
Yes.
About this?
Yes.
And what we did yesterday.
Yesterday's and today's. Okay, so 10, 1, 10, 2.
Oh, that's easy.
Okay, so we're going to estimate the product of 1/2 times 25, use compatible numbers. Okay, this is one of the situations to where you can have a different answer, you're going to be able to be okay. This is 25, right? We're counting by 2s, which means we're going to have 24, 25, 26. Now, correct me if I'm wrong, but we have always been taught that if you're right in the middle of 2 numbers, you round up. Haven't we? So 25 would round to what?
26.
According to your book, it's going to round to what?
24.
Because it's right in the middle. Here's my point. This would be one of those problems that if you got wrong, you could walk up to me and say, Mr. Bevel, I rounded up because it falls right in between the 2. Okay, you're right. You could also come up and say, Mr. Bevel, 24 is easier to find half of than 26. I don't know why 24 would be easier to find half of than 26, but hey, maybe because that's the number that you're more confident using. That would be okay. Remember, we're estimating.
Estimating.
Estimating means that you're going to have an answer that's close to another answer. It doesn't mean you're going to be perfect. Okay? So because of where this falls, they want us to use 24, which is about 12, correct?
Yes.
If for some reason you came in and you said, well, 1/2 times 26. And you had this. I could support that. You could come up to me and say, Mr. Bedwell, well, 25 is right in the middle of 24 and 26. Well, if it's right in the middle, you round up. Because I was taught if I was rounding to the nearest 10, and I had 0 and I have 10 and 5, you gave me the number 5, which falls right in the middle between 0 and 10. Which direction do you round?
Up.
You see why I can say, okay, I can support that?
Yeah.
But then it also uses this word compatible. So if you came to me and said, Mr. Bedwell, it is right in the middle, but 24 is a lot easier to work with than 26. Well, according to the definition of a compatible number, it's a number that's easy to work with, right?
Yeah.
Right. Well, that right there is an opinion. Mr. Bell, I know half of 26 is 13, so that's easy to work with. Mr. Bell, well, I didn't know half of 26 was 13, but I knew half of 24 was 12. Well, Okay. Estimating can be strange.
You're good.
Okay. Now, your homework. Or your classwork, I should say, because I think you're going to have plenty of time to finish it here in class. Compatible numbers. You need to count by the denominator. So in this case, our number 2, our denominator is what?
3.
It's 3. 3, 6, 9, 12, 15. The number below our number is 12. The number above it is 15. Is 13 closer to 15 or 13 closer to 12?
12.
So we're going to go to 12. So we have 2/3 times 12. Our denominator is?
3.
So you can make your bar graph. I need a number that's going to go here, and when you add it all together, it's going to give you 12. Yes. 4. So I have 4, 4, and 4. Now, top number tells me how many of those squares I need. What's my top number? My numerator? 2. I need 2 of these boxes. So what's my answer?
8.
That's what you're doing today. Okay. I just got asked to do number 5, so let's take a look at number 5. I'm not going to answer it, but I will help you set it up. 17 times 1/4. Oh, because the fraction's after it?
Same thing.
So the number 17.
You're really smart, Xavier.
All right, X. What's this? X, what's this? So what's the difference if this 1/4 is on either side of the 17? Is there a difference? No. They just confused you by putting the number in a different spot, huh? All right. Are we good? Okay, you guys have the next 15 minutes to work on your own.
Got it.
During that time, I will be asking if you finished your homework from last night or not. Also, if you need help, I am here. You can raise your hand. If you need help when you're at home, our video is up, and you can use that. All right, one second. People, we're working, not talking.